This video, we will do deductive reasoning for geometry. The objectives that we will cover is we will review the conditional, converse, inverse, and contrapositive statements, understand and use two laws of deductive reasoning, the law of detachment and the law of syllogism, and I will give you a lot of examples. In notations are really important, guys, because if you know the notation, even if you don't remember the whole sentence or definition for any statement, you can use the notations if you remember them, and then you can solve the problem. So the conditional, I'm reviewing first. So the conditional statement, the notation is conditional statement. Conditional statements. The notation for conditional statement is if P then Q. If P then Q, and that's how we write the notation. So I'm gonna also write it in parentheses, if P then Q. Okay, what is P? Please watch the video on conditional statements. I will link it above. Do you see the P is hypothesis, Q is conclusion. So I'm going to do that. P is hypothesis, Q is conclusion. Conclusion. Okay, that's a conditional statement. Let's do the converse. Converse statements. These two dashes mean statements, the same word. So if Q, in this case, we switch their places. If Q, then P. And it's going to say if Q, then P. That's converse. Converse, we switch the P and Q for from the conditional statement. Now, the third one is inverse. Okay, inverse is opposite. So it's going to be not P, opposite of conditional statement, okay? Not P, if not P, then not Q. Now, this squiggly line, this means not. So I'm going to just write it here. The squiggly line means not. Okay, so write it down. If not P, then not Q. Next one is a contrapositive statement. Contrapositive. Contrapositive is it's like a converse. Like the Q and P we switch, but with the not. So it's gonna be not Q. If not Q, then not P. If not Q, then not P. And guys, like I said, watch the video for conditional statement in detail, and I'm giving you in that video we will be able to see all these examples for the different statements. Okay, so let's do some of the examples about the conditional and converse and inverse. I'll just give you one example each, and then we go from there. Okay, if it is raining, then it is cloudy. So which one is the sentence, the phrase that comes after if is always P. Like we have a if P, then Q. That's a conditional statement, right? If P, then Q, conditional statement. So which one is my P? The hypothesis, this is my hypothesis P, and this is my Q. This is after then, that's a Q. So we're gonna say if it is raining, then it is cloudy. Hypothesis is it is raining. Conclusion is it is cloudy. Okay, for the converse, so this is actually a definite example of conditional statement. Okay, if it is cloudy, then it is raining, and you can tell we switched the Q and P's. Like it is cloudy, then we moved it up here, that's a Q, and it is raining, that was hypothesis P, then we moved it here. So what is this? If Q then P, that's converse. So this is converse. Okay, I switched the Q and P, and the statement is going to go if Q then P. Next, if it is not raining, then it is not cloudy, that's inverse. You can check, I did not switch the P and Q, but I have that not with it, like not P, if not P, then not Q, that's inverse. So this statement is inverse. Okay, because that's a P and that's a Q. Okay, let's do for the next one. If it is not cloudy, then now I switch the P and Q's, because that one was Q, that one was P, but since they're using not, so we are using that squiggly line for it. If not Q, then not P. This is my contrapositive example. Okay. Now let's do another example related to conditional statements. This is one. If a number is a whole number, then it is an integer. We know this is our conditional statement, right? So the question is, how do we write converse? This is a conditional statement. If P, then Q, right? This is P and that's a Q. That's P, that's Q. And that's a conditional statement. How do I write converse for this? Converse was if Q then P. I switch the conclusion and the hypothesis places. So since this is my conclusion, the converse I'm going to write here, converse. And I always write my notation with it. It helps me a lot. If Q, then P, right? This is my notation. So it means I have to move the Q to the after if. So I'm going to say if a number, you know, in the beginning after if, I'm not using a pronoun. I have to, instead of it, I want to know what this it is in the conclusion. It means a number. So I'm just going to write a number. That's a pronoun. If a number is an integer, comma, then, now up here I'm not using a number, I can use a pronoun, but after if, don't use a pronoun, like use a real number, a real word. Then it is a whole number. Okay, done. Next one we have is, let's change this to inverse. Now, if you guys pay attention, inverse was not P, then not, if not P, then not Q. That was inverse, right? Okay, so let's write it down. The notation first, not P, if not P, then not Q. And let's write it down. P and Q stays at the same place, but I'm just including P and not with it, right? So I'm going to say P is right there. If a number is not a whole number, is not an integer, I'm sorry, is not a whole number, yes, I'm right, is not a whole number, comma, then it is not an integer. You just have to memorize it, inverse converse notations, and you will be fine. Okay, the next thing we need contrapositive. So let's change that to contrapositive. I need my notations first for the contrapositive. In the contrapositive notation, you switch the QP but with a not. If not Q, then not P. That was the notation. So let's switch their places, and remember, after if we are not using a pronoun. So if a number is not an integer, comma, then it is not a whole number. Then it is not a whole number. And I will say one more time, after if, please don't use a pronoun. I'll just write it down here, okay? After if, don't use pronoun. So you guys don't forget that. Okay, so that's contrapositive. Now let's talk about deductive reasoning and inductive reasoning, right? Deductive reasoning is the process of proving a specific conclusion from one or more statements. A conclusion is proved true by deductive reasoning, and we call this theorem. So easy way, inductive reasoning is, we did this before, but I'm just going to repeat it. What's the difference? Inductive reasoning is observing patterns or examples and then using them to form a general conclusion that may or may not be true. So inductive reasoning, when we observe something or we see examples, then we just conclude something, but it doesn't mean that conclusion is true. May or may not be true. But for deductive reasoning, we use known information, like a logical argument that arrives at a specific conclusion that is true. This is how we prove theorems. So for the deductive reasoning, there should be some logic behind the statement, like using known information, right? Like we know something, and then for sure that's true, and then we arrive at the specific conclusion. So this is deductive reasoning. Okay, the deductive reasoning has two laws: Law of Detachment and Law of Syllogism. Okay, so let me write it down. Since we are talking about deductive reasoning, so I'm going to write here about the deductive reasoning. Deductive reasoning. The definition was using known information. Known information to write a logical argument. That arrives at a specific conclusion. That is true. Okay, so in inductive reasoning, remember, we observe the patterns and examples, and the conclusion may or may not be true. Okay, but this one, the conclusion must be true, and we use known information. Okay, so let me give you an example for the law of detachment. Like I said, we have two laws of detachments here, two laws in the deductive reasoning. The first one is law of what is it called? Law of detachment, detachment, the one we will talk about, and the other one is law of syllogism. So law of detachment, I'm going to give you a definition for that. Law of detachment first. So law of detachment, law of detachment. If P then Q, if P then Q is a true conditional statement, is a true conditional statement, true conditional statement, and P is, which was hypothesis, is true, then Q is true. Okay, so if P is true, hypothesis is true, then Q is true. Okay, let me give you an example. Okay, if an animal is cat, then it has a tail, right? So this one, what I'm talking about, this is my conditional statement. This is P and this is Q, right? This portion is Q, this is P. So this is a true conditional statement, right? Now, what is a hypothesis? What is P here? P is, for example, I'm going to give you an example for it, okay, specific example. P is Onyx is a cat. Okay, that's the name of the cat. Onyx is a cat, therefore, these three dots means, therefore, Onyx has a tail. Right? That's law of detachment. Okay, the P is true, then Q is also true. Okay, let's go for this example. Next one. I'm gonna move this up there so I can have enough space. Okay, here we go. Now in this case, let's try. If a student is in Algebra 2, then that student took geometry already. I mean, if you look at it, the conditional statement is true because P is true, then Q is true, right? If a student is in Algebra 2 class, then that student took geometry already. So that's a true statement, right? True conditional statement. And we can say the hypothesis is, for example, Jennifer is in Algebra 2. Conclusion is, therefore, Jennifer already took geometry. Right? Because it goes in order. I mean, everybody knows that the students have to take geometry first before they go to Algebra 2. Okay, so these are the law of detachments. If the conditional statement is true, if PQ is true, then it means this hypothesis and conclusion has to be true. Okay, what is the law of syllogism? Now let's do the law of syllogism. Okay, I'm going to write down my law of syllogism here. The definition, we'll try to understand it, and then I'll give you example for it. Okay, law of syllogism. Law of if P then Q is true, you know, if P then Q means conditional statement, right? If P and true, if conditional statement is true, and Q, if Q then R is also true, then P R is a true conditional statement, is a true conditional statement. Okay, now the example that I have, it's really simple. if you guys pay attention, for the law of syllogism, the easiest way is to remember the you make sure that you remember the notations. Like the notations are if P then Q, right? If P then Q, then conclusion is to another R, and P and R, the hypothesis of the first one and the conclusion of the second one, supposed to be true. You can tell. Oh, not Q, it's R. Okay. If P then Q, if hypothesis then conclusion, right? Then from here, if conclusion then another conclusion, then I have if hypothesis then the second conclusion. They are true. Okay, so let's try and do this. If the car has gas, this is P, then it will start. That's the Q, right? And I'm going to use a different color. Then this is Q. If the car starts, you see I picked the conclusion, the Q. If the car starts, right? I pick with the if. So if the car starts, this is Q. I shouldn't be using a different color. I'm using that. This is Q, right? Then you can go out. That's R, right? So if I say this something like this, and this is what the statement they are giving me in the question, and they're asking apply law of syllogism. So I know if the car has gas, then it will start. That's true. That's a true conditional statement. But if the car starts, then you can go out. That is also true, right? Both of these conclusions in the hypothesis in the or, they are all true. So I can apply my law of syllogism. It's going to be if, okay, not this color. If, that's the same color with the P, okay? If the car has gas, which is this portion I'm working on, okay? P, I'll pick P. If the car has a gas, comma, then you can go out, which is in purple color. Then you can go out, which is also true, right? Go out. So this is R, and this one is my P. So if you guys watch this, if P then Q, Q then R, I can make an arrow there, but I can write there, Q then R, then I picked up this whole thing, which means P to R. And this was law of syllogism. So, and you can tell both of these conditional statements are true in the top, this one. But if I write, if the car has gas, then you can go out, which is also true. So this is law of syllogism. So just remember these notations. It would help you big time. And in the this one, the law of detachment, make sure that you understand the if P and Q is a true conditional statement, then P is true, then Q is true. Okay, if the whole conditional statement is true, then it's hypothesis, and then the conclusion is also true. So please comment below. Let me know if you need more examples. I will make up some more examples, and I will help you out. Please subscribe and like my video. Thank you so much. Bye.